All right, so looking at our first and only example here, but it's got a couple different parts to it. Part A is asking me to list the relative minimum points. So knowing from those notes, those relative minimum points are like my valleys or my low points. So looking at that on the graph, any kind of valley, this piece right here, this would be a relative min, as would this be a relative min. This other one at the end would not be a relative min because it's not at the bottom of a valley. It just stops there. We don't know if it keeps going or whatnot. So my relative min points would be 1, 2, 3, 4, 5, negative 5, comma, negative 1, and 1, 2, comma 2. The absolute max and min, so the absolute min would be down here, because that's the absolute lowest point. Notice how the absolute min and relative min are the same. They match, and that's okay. And your absolute maximum point would be all the way up here. So your absolute max, notice how I'm labeling these or putting an arrow. The absolute max is going to be negative 1, comma, 1, 2, 3, 4, 5, 6, 7. And then my min is that 1, 2, 3, 4, negative 5, comma, negative 1. The y-intercept, again, that's where it crosses the y. Let's not cover that so we can't see it. Where it crosses your y-axis, which would be at this purple point right here, which is an x value of 0, because that's what a y-intercept is. 1, 2, 3, 4, 5, 6. Okay, so this is a perfect example right here of one of those intervals. That's an interval. Interval example. So is the function decreasing from negative 5 to negative 1? So that's saying that when the x value is between negative 5 to negative 1, what's happening to the graph? So let's get a visual of this on the graph. So negative 5 on this graph is 1, 2, 3, 4, 5. Negative 5 starts right here. So I'm just going to draw that line there. That's the line x equals negative 5. And then negative 1 is right here. What's happening between these blue lines? What's going on with that function? Is it increasing or decreasing? Well, you can see that that function is going up, so that would be increasing. Increasing because it's going up. Swoop. Okay, part E wants me to list the zeros. Remember from our newly learned notes that zeros are just another name for x-intercepts. And remember here, we can have more than one. So x-intercepts, anywhere this graph crosses the x-axis, which is right there and right there in 2 spots. So your zeros are, and we can just write these as x equals negative 1, 2, 3, 4, and x equals negative 4, negative 5, negative 6. Or you can write them as the coordinate points, negative 6, 0, and negative 4, 0. And last but not least, here they want us to state an interval. So I'm just going to copy that interval format right from up there. That x is in the middle, keep those less than or equal to's, and then I'm going to fill in with the numbers. State an interval over which f of x is greater than 0. So remember from our previous notes that f of x is really just y. So this is asking me where y is greater than 0. So if I go to my graph, the y's are greater above this line right here. Anywhere above this line, the y's are greater than 0. So just pick some x values where that is greater than 0. I'm going to start right here at -1, because why not? And you could start it at -2, -3, -4, or -5, just not at -6 or -4. Sorry, I said 4. Just not at -4, because that would be equal to 0, not greater than. So I'm going to start from -1 and go all the way to 1, 2, 3, 4, 5, 6, 7. So the y value is positive when the x value is -1 all the way through 7. All right, that's it. That's all for graphical features.